3.1 quadratic function. So you can see the parabola here in the graph to the right. And so we've actually already graphed these when we were using our transformations. So if you remember, the parent function for this was y equals x squared. And so we're just going to go a little bit of a deeper dive here. And so, as mentioned, this is a quadratic function. In the picture, we call that a parabola, the shape of the graph right there. The parabola is going to have a vertex. And so there's our vertex right there. And then we have a line of symmetry. Okay. And so that basically cuts the graph in half, where it's symmetrical across this, to where if you were to fold the graph at that line, it would fold on top of each other, the two sides of this. Then we have a y-intercept right here. We hit the y-axis right here. Then as far as the x-intercept, you can actually have 0, 1, or 2 x-intercepts. Typically we have 2, but sometimes we'll have 1 and sometimes we'll have none. And so we'll look at each case. And then here are some more formal definitions of what we're looking at. So the vertex is the highest, or it could be the lowest point of the graph. So in this case, it's the lowest point of the graph. And so the maximum or minimum value of the parabola is the highest or lowest point. So in this case, this would be a minimum value right here because it's the smallest. So there is no maximum because the graph goes up forever. Now, sometimes the parabolas will open downwards like this. And so this would be my vertex right here. And this one would actually be a maximum right there. So the vertex and minimum and maximum go together. Then axis of symmetry, we already kind of talked about that. It's always going to slice right through the vertex. And so we're going to come up with an equation for that line in a moment. And then the x-intercepts, I just want to mention that sometimes they're referred to as zeros, solutions, or roots. So you're going to see all those different vocabularies. So sometimes they'll say find the solutions, find the roots, find the zeros. And what they're talking about is, if you're looking at it in terms of a graph, we're talking about the x-intercepts right here. The y-intercept, that's pretty self-explanatory. That's where we're going to hit the y-axis right there. Okay, so let's go ahead and look at a couple, or actually, let's go ahead and find all those details here. So let's see, the vertex, we're going to give an ordered pair for that. So let's see, that one's going to be at 1, -4. Right there, that's the vertex, that's the point right there. So then the axis of symmetry is this vertical line. And so if you remember back from maybe a previous math course, vertical lines have the equation's going to be x equals. Well, what's the x value for all the points on this dashed line right here? Well, they're all 1. And so what you'll notice is that the axis of symmetries, you got to have the x equals. It's always going to be x equals, and it's always going to be the x value from the vertex. So you'll notice that pattern right there. So that's the equation of this vertical line right here, x equals 1. Then it's asking if the vertex is a maximum or a minimum, and so I already mentioned that in this case it is going to be a minimum. Then the y-intercept, let's see, that looks like that's going to be at 0, -3 as an ordered pair right there. And then the x-intercept, we actually have 2 of them. So the first one would be at -1, 0. And then our other one would be at 3, 0, over 3, 0 right there. And then the last thing they're going to ask is the range. Well, remember the range is the y values, and so our lowest point is -4 in terms of y, and it goes up indefinitely. So this would be from, and we're going to bracket in the -4 because we want to include it, and then we go all the way up to infinity like that. All right, so the next part's just going to be more of the same. So if you'd like to, just go ahead and pause the video and see if you can answer this. And I'm just going to go ahead and move on. So right here, let's see, the vertex is going to be at, let's see, that's at 2, 4. Okay, over 2, up 4. Axis of symmetry, once again, that's going to be this line that cuts it in half, and that's going to be at x equals 2. It's just the x value from the vertex right there. This time, that is our maximum. And if you want to list what the maximum is, it's going to be a 4, right? That's as high as we go, is 4. Let's see, the y-intercept, that's interesting. That's going to be at the origin right there. So that's going to be at 0, 0. And so it turns out that that's actually also an x-intercept, right? So at 0, 0, I have an x-intercept. And then also right there at 4, 0. Now for the range, this time it goes down indefinitely, but we peak right there at our maximum. So, but you want to go from low to high, so we have to put the negative infinity first. That's very important. And then we peak up here at positive 4. Okay, our next one here. So let's see, the vertex is right there. That looks like that's at negative 1, 0. Once again, that axis of symmetry just cuts right through the vertex. So it's going to be x equals negative 1 is the axis of symmetry. Then this time it looks like that's going to be a minimum point, and the minimum value, that y value, is 0. Then it looks like we have a y-intercept right here at 0, 1. And this is one of those cases where we only have one x-intercept, and it's actually going to be what the vertex value was. So that's at negative 1, 0. That's my x-intercept. And then my range, let's see. So my lowest, there is a bottom. I am bounded at the bottom at 0. And then I'm unbounded going up. I go up indefinitely, so that's where the infinity symbol comes in to represent that. Okay, I have one more that looks like this. All right, so once again, we'll start with the vertex right here. So that looks like we're at negative 2 up 1. Axis of symmetry, once again, just cuts right through that. So it's just going to be x equals negative 2. This time it looks like we're dipping, we're bottoming out right there. So it's going to be a minimum right there. And that minimum value occurs at y equaling 1. Then our y-intercept, we hit the y-axis right there. It looks like that's at 0, 5. And then x-intercept. Okay, I don't have any this time, so none. And then for the range, once again, we have a minimum at 1. And then we go up indefinitely. So we go up to so we put infinity for our maximum because it continues to grow. Okay, so that's kind of like a little introduction to these. And so now what we're going to look at is how to graph them when given an equation. And so the first one we'll look at is if we're given the equation in standard form. So here's the equation for standard form. F of x is equal to a times x minus h squared plus k. And so this should kind of look familiar from our transformations. The minus h and the plus k causes your horizontal and vertical shifting. And then the a in front could cause a reflection or a stretching. Okay. And so let's look at this right here because this is going to give us some interesting information here. So the point HK is the vertex of the parabola. So those two values right there actually will give you your vertex. The parabola is symmetrical with respect to the line x equals h. So we've already saw that from up above. And then also, if a is greater than 0, the parabola opens upwards. So it's going to open like this. And if a is less than 0, basically if it's negative, if the front value is negative, that's what I was talking about earlier about a reflection. It's going to make the parabola reflect down to where it's going to open downward. So let's go ahead and kind of jump in here. So right here it says for the quadratic function given, state the vertex, how it opens, the axis of symmetry, and the intercepts. Then graph the function and give the range. Spoiler alert, the domain is always going to be from negative to positive infinity for quadratic functions. So you'll notice on your homework sometimes they'll be asking you for the domain, and I don't really go over that too much here because they're all going to be from negative to positive infinity. So they all are going to have that domain. But just be aware you might be asked that in the homework. Okay, so we have to be a little careful here. So it says to find the vertex, right? And so the vertex, you've got x minus 3 and then squared and then minus 1. And so if you notice, there's a minus here as part of the formula. So what that means is my vertex, my x value is actually going to be 3 right here. A lot of times students just try to remember it's the opposite of what's here because I have a minus 3, so they put a positive 3 here, right? And then the the y value is going to be exactly what you have right here. So it's going to be negative 1. So it's the opposite and then what you have here. So positive 3, and then I had that minus 1, so I put a negative 1 here. But I want to show you why that is, okay? So remember, the vertex is going to be either the highest or the lowest point, right? Well, you know, the a value is in front right here. And in this particular example, it's a 1. So remember, if a is greater than 0, basically, if the front value is positive, it's going to open up, right? So what does that mean? It means it's going to look like this, right? So what that tells me is that the vertex is going to be the lowest point, right? That's going to be the minimum point right there. And so why is that the vertex? Well, because if I were to evaluate this function at f of 3, what happens is I'm really actually looking for what's going to zero this out. What's going to cause this to turn into 0? And that value is going to be the opposite of what's here, because what happens is when I plug in 3 for x, I'm going to get 3 minus 3 squared, and then I have that minus 1 right there. And what happens is this just is going to turn into 0 squared, which is 0. And then I still have that minus 1, which gives me a negative 1. So that's why the y value is that k value that's on the back end right there. It's whatever that is on the back end. And so that's going to be the vertex, and that's also going to be the minimum value, because if I plug anything else in, even negative numbers, it doesn't matter what I plug in. If I plug in anything other than 3, what's going to happen is I'll get a positive result because it's being squared, right? I'm going to square it. So even if I plug in values that give me negative results here, once I square it, it turns positive. So the point is I really have nowhere to go but up. So let me go ahead and plot that point. And then I want to plot a couple points around it just so you can see that. So over 3, down 1. Okay, so that's going to be my lowest point right there. The parabola is going to open up from here. So for example, if I were to plug in f of 2, okay, that would give me, let's see, 2 take away 3 squared and then minus 1. So yes, this will turn into a negative 1, but once I square it, it's going to turn into positive 1. 1 minus 1 is 0. So right there, at when x is 2, my return value, my y value, was 0. Okay. Now, if you remember, at the vertex, a vertical line goes through it, and that's the axis of symmetry. And so now you can kind of see one of the benefits of that. And so, by the way, that would be at x equals 3. And one of the benefits is whenever you find a point, you can reflect it across that axis of symmetry. So this point right here can reflect over here, and so I have another point over here. And pretty much I can graph this now. And so when you're doing your homework and you're graphing this, you want to make sure you're going to have different tools for the different graphs. Like you'll have your line graph and you'll have your parabola, and you might have a couple other ones. You want to make sure you pick the parabola, and you always want to start with the vertex and then pick any other point. It doesn't really matter which one you pick, and it should populate on your screen, and we should end up with something kind of like this. Now, technically, I've already found the x-intercepts, but they're not always going to be that simple. So I do want to go over how to find them algebraically. So that's what I'm going to do here. So I'm going to go ahead and erase this so I can show you that. Okay, so if you want to find an x-intercept, by definition, if you want to find an x-intercept, you have to let y equal 0, or in this case, you let f of x equal 0. Because remember, f of x is just function notation for y, right? So what I'm going to do is I'm going to set this. I'm not letting x equal 0. I'm letting f of x be 0. I'm letting y be 0. So 0 equals, and then I have x minus 3 squared minus 1. And then this is actually, this goes back to our first unit. And so you have to solve this by using the square root property. So first you have to isolate the squared quantity. So I'm going to add 1 to both sides to get started. So now I have 1 equals x minus 3 squared. Now the square root property, let me refresh y'all on that. So basically, if you were to have, let's say, x squared equals some number, we'll call it k, then that's equivalent to x equaling the square root of k, or x could be equal to the negative square root of k, and either one should satisfy the original equation up here. So that's the square root property. Now, a lot of times what we did was we used the plus or minus, so I didn't have to write it out twice. So what I would do here is I'd square root, and I'd have a plus or minus out in front. So that represents the two equations here, the positive and the negative. So the square root of 1 is just 1. So I end up with plus or minus 1 equals, and then the square root's going to nullify the square. So we have x minus 3. And you can leave it like this, but typically I like to kind of work with my x on the left side. So a lot of times I'll just kind of flip-flop the two sides. So x minus 3 is equal to plus or minus 1. Okay. And then what we'll do here is we'll go ahead and add 3 to both sides. And if you remember when we covered this, I just kind of wedge it here between the equals and that plus or minus. So I end up with x equals 3, positive 3, plus or minus 1. And now I can actually go ahead and figure out the plus and the minus. So I want to go ahead and do that. So what I'm going to do here is you look at it as being 3 plus 1 or 3 minus 1. Well, 3 plus 1 is a 4, and 3 minus 1 is 2. So now I figured out where my intercepts on my x-axis are. They're at 4 and 2. And so on the homework, you're going to want to list them as ordered pairs. So it's going to be at 4, 0, and then comma 2, 0. And the order you list them should not matter. And so you can see them right there. There's the 2, 0 right here. And then the 4 zeros right there. Okay, y-intercept. Okay, now for the y-intercept, the definition of that, so if you want to find your y-intercept, you're going to let x equal 0. So this time we actually let x equal 0. So let me look at my equation up here. So let's see. All right. So f of 0 is going to be equal to 0 minus 3 squared, and then minus 1. So I plug that into the equation up here. So plugged in 0 for x. And then just simplify this, and you should have your y-intercept. So let's see, this right here would become negative 3 squared minus 1. Well, negative 3 squared becomes positive 9. 9 minus 1 is 8. And then once again, I want to list that as an ordered pair here. So that's going to be at, I let x equal 0, right? So I let x equal 0, and my result was 8. And there we go. And then the last thing is our range. So looking at the graph, you can tell right here that we bottom, our lowest y value is going to be at negative 1, and then we go up indefinitely, so infinity. Okay, so I'm going to go ahead and stop part 1 here and pick up on the next example.